Alright, so hopefully you ladies had a couple minutes or at least a chance to think about either how to graph or actually tried it out. So to start off here, we have y is equal to x squared minus 3x minus 4. I'll divide that by x minus 4. So what we're going to do is we're going to rewrite this, I guess we're going to simplify it by factoring. So we have y is equal to, and here if you guys want to use your product and sum, you have a product of negative 4 and a sum of negative 3. So think about what two numbers will give you a product of negative 4 and a sum of negative 3. So if you guys think that is negative 4 and positive 1. So we can rewrite that middle term. So we have x squared minus 4x plus x minus 4, divide that by x minus 4. And remember, it doesn't matter which order you put your negative 4 or plus 1x. As long as you get the right numbers in there, that's all that matters. So from there, we can factor out any common factors between the two groups. So in our first group, we have a common factor of x. So what we're left with is x minus 4. And in our second group, there's nothing in common there, so we can just pull out a 1. So we can go plus x minus 4. That's all divided by x minus 4 there. Then, continuing on with our factoring, we'll pull out that common factor. So we have y is equal to x minus 4. What we're left with is x plus 1. That's all divided by x minus 4. So as soon as that one is there, is fully simplified, what we can do now is, let's cancel out some common terms. So this one actually works out very nicely. So we have x minus 4 and x minus 4 here. And what we're left with is y is equal to x plus 1. So what's going to happen here is that from here, this one's going to be really nice. We have here a linear equation. And so when we're doing our table values, I'm just going to scroll on down here for just a quick second. So what we're going to do here is, just like last section, we want to make sure that we have our point or non-permissible value somewhere in the middle, and then we'll graph values above and below. So here, if you guys set that equal to 0, so here we have x minus 4 is equal to 0. So our non-permissible value there is x is equal to 4. And if you guys note, those ones were common factors, so that means that we have a point of discontinuity. Alright, so here we're going to put 4 in the middle, then we're going to graph a few above and a few below. And you don't have to go to a whole bunch of different places because this is a linear equation, so it should be a straight line. Okay, so we can even go up to even 5 and maybe 3. And I guess if we want a number that's not also not our permissible value, we should also go with maybe 1 also as well. So we'll go with 2. So now we'll put x is equal to 5 in our y is equal to x plus 1. So we have y is equal to 5 plus 1, which is 6, 4, and remember we have that point of discontinuity. So yes, we have x is equal to 4, but we also do have that point. So what happens when x is equal to 4? We have y is equal to 4 plus 1, which is 5. But also keep in mind this is your hole here. So we gave it as a coordinate, but just remember this is where your hole is, so don't actually graph that there, okay? Then for x is equal to 3, we have 3 plus 1, so y is equal to 4. And then we have x is equal to 2, so we have 2 plus 1, which is 3. And if you notice, it follows that same pattern of a linear equation, so they all move up by the same common factor. And from here, we can graph it. Alright, so here our biggest x value was 5. So we can label our spacing. Every 2 tick marks will be 1 unit. And here our biggest y value was 6, so we might even want to go up by 2s this time. Alright, so once when you get your line spacing all sorted out, from here we can start graphing. So our first one there, we had 5 and 6. Then we had 4 and 5, and this one here is going to be our hole. Then we had, let's go scrolling down here, then we had 3 and 4. Then we had 2 and 3. And from there we don't need to go any further. From here we just connect our dots and create a straight line. So if you guys can, please use a ruler. This one's probably going to be super shaky, me and my shaky hands, so try your best to create a straight line. I definitely encourage you guys to use a ruler for this. Alright. That one was pretty shaky there, so hopefully you guys did a better job than I did. So the big key thing here is that I want to point out here is we have our hole here at 4 and 5. So it doesn't go in as a circled dot, it's an open hole dot. So that way we can see that there's a hole there and that our graph actually won't touch 4 and 5. Okay? And I guess our one last thing here is we also need to label our graph. So we don't want to be labeling it y is equal to x plus 1 because this doesn't show us our hole there. So we want to label it with our original equations. So we have y is equal to x squared minus 3x minus 4 over x minus 4. Okay. And then to finish off this question, here it says to analyze its behavior near its non-permissible value. And so here we're just going to be talking about, so what's happening at this hole. So scrolling down just a little bit here. So here what we can say is that, say this graph is increasing. So going from left to right, it's increasing graph. And it follows the pattern of, and we can say that it'll look pretty similar to x plus 1 apart from that hole. So it follows a pattern of the equation y is equal to x plus 1 and has a point of discontinuity at, and we'll give the coordinate there, so that one there was 4 and 5. Okay? So just talk about, so what's happening at that say non-permissible value. So there was a hole, and so what happened was that graph acted or behaved like y is equal to x plus 1 apart from that hole. So make sure you say it follows that pattern of this graph, and then it has this point of discontinuity, which kind of helps separate it from actually being y is equal to x plus 1. Okay? So now let's move on to question number 2. And this one here, I'm going to absolutely encourage you guys to use your own, to use your graphic calculators, or maybe if you guys don't feel quite so confident with it, then definitely try graphing it by hand. Okay, so in question number 2 here, we need to compare the graphs of f of x is equal to x squared plus 4x plus 3 divided by x plus 1. And then we also have g of x, which is x squared minus 4x plus 3 divided that by x plus 1. And so once when we graph these, we should talk about any differences or even maybe some similarities that we can see between these graphs. And so just to first off note, these equations are almost identical, apart from this middle term here being positive 4x and negative 4x in our second function there, okay? So if you guys want to, I'm going to graph these ones by hand, but you guys are more than welcome to use your graphing technology. So I'm just going to scroll on down to create our table values there. So for our first function here, we have y is equal to x squared plus 4x plus 3. I'll divide that by x plus 1. And so here I'm going to simplify. We're going to factor out the numerator, so we have y is equal to, and you have a product of 3 and a sum of 4. So what we'll have is x squared plus, that'll be 3x plus x plus 3, divide that by x plus 1. Then from there we'll take out our common factor, so we have y is equal to x is our common factor in our first little group. So we have x times x plus 3. And in our second group, there's only that common factor of 1, so we'll pull out a 1. And that is x plus 3. I'll divide that by x plus 1. Then from here, we'll take out that other common factor of x plus 3. So we have x plus 3. And what we're left with is x plus 1. And that's divide that by x plus 1. Alright, so from here what we can do is, here we can already see our point of discontinuity. So this one here I'm just going to write up here, so our point of discontinuity, because we can cancel out x plus 1 and x plus 1. So we have our whole there. So here we have x plus 1 is equal to 0. Moving 1 over to the other side, we have x is equal to negative 1. And to find that coordinate, we're going to put that into our simplified equation. So we have y is equal to x plus 3. Then, so putting negative 1 in for x, we have y is equal to negative 1 plus 3, and that's 2. So that means that our whole is at negative 1 and 2. From there we can create our table values, or if you guys can maybe easily graph y is equal to x plus 3, but it's up to you guys. I like to do table values just to double check. So you have x and y here. Make sure you have your whole or your non-permissible value somewhere in the middle. So here we have x is equal to negative 1 and 2. And just so I remember, I'm going to write whole there, just so I know not to actually graph that as a closed dot. So from there we can choose some values above and below. This is actually it's linear, so we don't need to choose a whole lot of values there. As long as we see enough points to create that line, that's all that matters. So here we have, let's go with say negative 2 and 0 and 1. I'll keep some nice easy values there. So putting in negative 2 in for x into x plus 3, we have negative 2 plus 3, so y is equal to 1. Putting 0 in for x, we have 0 plus 3, so y is equal to 3. And then putting 1 in for x, we have 1 plus 3, which is equal to 4. So it should here be enough to graph. So I'm going to go ahead and graph. And so first off, we're going to label our spacing on our graphs. We have 1, 2, you guys could even go with smaller values, but either way that works, or bigger values, so spread them out more. Alright, so now we can move on to graphing. Now we've labeled our spacing. So our first value there was at x is equal to negative 2 and y was at 1. Then we had our whole, which was at negative 1 and 2. So just remember, make that one actually a whole. Do not color in that circle there. Then we had 0 and 3. And then we had 1 and 4. And you guys are going to use a ruler. I can't exactly use a ruler on our computer. So this is going to be a bit of a shaky line, but hopefully yours will look 10 times better than mine will. Alright. Hey, not bad on my part. Hooray. Okay. And then so one thing is just make sure you label it. So we have y is equal to x squared plus 4x plus 3. Divide that by x plus 1. Okay? So make sure you label it as that original function there, and make sure you have that whole there. So don't color it in, or else I'll think that you actually graphed it and it's an actual point on it. Okay? So now we're getting up to that 15-minute mark, so we're going to switch over to video 2 to complete the rest of this question.